Hello everyone, in this video we will learn about arithmetic progression, its general term and the sum of n terms, and also some of the properties of AP. See, we have already learnt about the progression in the previous video, that a progression is a sequence whose all the terms follow a particular rule. Same is here about arithmetic progression. An arithmetic progression actually is also a sequence in which we find that every term is obtained by adding a constant in the preceding terms except the first term. So when we write the definition of arithmetic progression, that will be a sequence in which all the terms except the first term are obtained by adding a constant to the preceding term. That is the definition. For example, suppose we have 4, 7, 10, 13 and so on. This is a sequence. In this sequence, what we find, every term is obtained by adding 3. Hence, it is an AP. For every AP, the first term is represented by A. The first term of an AP is represented by A. And the constant which we are adding to each term to get the next term, that is known as the common difference. And this common difference is represented by D. The common difference is represented by small d. Therefore, when we want to consider any of the AP, then we can write in the form of A and D, and that is known as the general form of an AP. So what is the general form of an AP? We can write general form of AP, that will be A plus D, A plus 2D and so on. We can also say, if there is a sequence that is A1, A2, A3 and so on, it is an AP, that is arithmetic progression, if we find A2 minus A1 is same as A3 minus A2 is same as A4 minus A3 and so on, which is D. It means to check any of the sequence whether it is an AP or not, we will find the values of the reference between the consecutive terms, and if it is same, we can say it is an AP. To learn about the general term of an AP, we can say it is AN. AN means nth term of the AP, that is represented by A plus n minus 1 into D, where A is the first term and D is the common difference. Let's see how this formula is derived. See, suppose the AP is, let the AP be A plus D, A plus 2D, A plus 3D and so on. This is the general form of the AP. So here we find A1 is equal to A, which can be written as A plus 0D or not, and which can be further written as A plus 1 minus 1 into D. The second term A2 is A plus D. We can also write this as A plus 2 minus 1 into D. A3, The third term is a plus 2d, which we can write as a plus 3 minus 1 into d. So what we are finding here is that the coefficient of d is 1 less than the number of term. As we find here, the first term is having the coefficient of d as 1 minus 1. Second term 2 minus 1. Third term 3 minus 1. And if we go in the same order, then will we find that an will be a plus n minus 1 into d or not? It means the coefficient of d will be n minus 1. This formula is only known as the general term of the AP, by which we can find out any of the required term of the AP. We can understand the concept in a better way by taking some example. So let's take one example here. Suppose we have an example, find the 12th term of the sequence, that is 3, 8, 13 and so on. Now to find out the solution, first we have to see whether it is an AP or not. So we write the solution this way. First we write the sequence which is given to us, that is 3, 8, 13 and so on. Here we find A1 is 3, A2 is 8, A3 is 13. What is A2 minus A1? That is equal to 8 minus 3 is 5. A3 minus A2, that is 13 minus 8, that is also 5. So we can write, since A2 minus A1 is same as A3 minus A2 is equal to 5, therefore it is an AP. And like this we can check whether a given sequence is an AP or not. And after finding that it is an AP, we can write here A, that is the first term, is 3. Common difference D is 5, and the term which we have to find is 12. So N will be equal to 12. And we can write the formula An is equal to A plus N minus 1 into D. Using this formula, if we write N as 12, we will have A12 is equal to A means 3 plus 12 minus 1 into D is 5. That is 3 plus 55 equal to 58, which is the answer. So like this we can apply the general term and find out the required term. Like here 12th term is 58. Let us take one more example where we can apply the concept of general term. And the example is, find the AP whose 4th and the 7th terms are 11 and 20 respectively. What we do to find out the solution of such problem, first of all we will consider the AP in the general form. So we write, let the AP be A plus D, A plus 2D and so on. Now we will write the general term. We know the formula that An is equal to A plus N minus 1 into D. It means what is A4? Fourth term is given here. A4 is A plus 3D, and that here has been given as 11. We can consider this as first term. What is A7? A7 will be A plus 6D, which is equal to 20, and we can consider this as second equation. This is a pair of linear equations in two variables, and to find the solution we can subtract the first from second. So we can write 2 minus 1, and if we subtract A and A will cancel. This will give you 6 minus 3, that is 3D equal to 20 minus 11 is 9. It means D is equal to 9 upon 3, that is 3. After finding the value of D, we can substitute that in 1. So we can write substituting in 1. We will get A plus 3 into 3 equal to 11. It means A equal to 11 minus 9, which is 2. Now after finding the values of A and D, we can write here A is 2, D is 3. Therefore, A plus D will be 2 plus 3, that is 5. A plus 2D will be equal to 2 plus 2 into 3, that is equal to 8. Therefore, the required AP is equal to 2, 5, 8 and so on, and this is the answer. Like this we can find out the AP if its two terms are given to us, and in case we are asked to find out any other term of this, then also we can make use of the general term and find that. Let's learn now how to find out the sum of n terms of an AP. So we write here sum of n terms of an AP. Suppose the AP is A plus D, A plus 2D and so on, and there are n terms in it, so nth term can be written as an. And we know the formula for an, that is A plus n minus 1 into D. Suppose this nth term we represent by L. If the sum of n terms is S, can we write this as A plus D plus A plus 2D plus so on, and the last term here is L. But suppose we want to go from the last term in the reverse order, will we find that the second last term will be L minus D and the third last term will be L minus 2D. Like this we can write all the terms till last. If we write the sequence from the last term to the first term in the reverse order, then also we can say the sum of all these terms has to be same, because let the order be changed, the sum of the numbers will be always same. So we write S is equal to, if we start from there, this will be L minus D plus L minus 2D plus so on, and the last term here will be the first term here, that is A, second last will be A plus D, and the third last term will be A plus 2D. If we add these two, we are writing here adding, we will get S plus S, that is 2S. If we add this, we are getting A plus L. If we add these two, D and D will cancel, this is also A plus L. Here 2D and 2D will cancel, this is also A plus L, and so on. Here 2D and 2D cancel, this is A plus L. Here also it comes as A plus L, and here also it comes as A plus L. So all the terms are A plus L each. And how many terms they are? They are n terms. Now we know if we are adding A plus L n times, the sum of that will come as n into A plus L or not. See here we get S is equal to n by 2 into A plus L or not. This becomes the first formula to find the sum of n terms of an AP, where last term is L. We can also write this as n by 2 into A plus an, to understand an and L is same. So to find out the sum of n terms of an AP, we can make use of the formula n by 2 into A plus an if the last term an is known to us. But suppose it is not known, we can put the formula for an here, and that will be n by 2 into A plus n minus 1 into D, which gives us n by 2 into 2A plus n minus 1 into D. This also becomes the formula to find out the sum of n terms of an AP. The only thing is we have to remember that this is to be used when last term is known to us. If the last term is not known, then we will be using this particular formula. Let's take one of the example now to understand how to apply the formula for sum of n terms. See here we have been given a question, find the sum of 12 terms of the AP 4, 9, 14 and so on. To find the solution of this, first we write the AP which is given to us is 4, 9, 14 and so on. Here A is equal to 4, that is the first term of the AP. D, that is the common difference, is 9 minus 4, 14 minus 9, that is equal to 5. We are to find out the sum of 12 terms. So n will be equal to 12. Now we know the formula of sum of n terms. We can also write this as Sn. Sn means sum of n terms. That is n by 2 into 2a plus n minus 1 into d. Therefore, the sum of 12 terms S12 will be 12 upon 2 into 2a. A means 4 plus n means 12. 12 minus 1 into d, that is 5. And that comes as 2 6 are 12. So it is 6 into 8 plus 11 into 5, which is 6 into 8 plus 55 to 6 into 8 plus 55, or we write 6 into 63, which on multiplication comes as 18, 6 6 are 36. So we find the sum of 12 terms of the given AP is 378. Now we will learn about some of the properties of AP. The first one is, if A, B, C are any three numbers are in AP, then we know that the difference between the terms should be equal. It means B minus A should be equal to C minus B. If we use the transposition, we are getting B plus B equal to A plus C. It means 2B is equal to A plus C, which gives us B is equal to A plus C by 2. It means if there are three numbers which are in AP, we find that the middle term is the average of the first and the third term. The second property, we can combine two properties in one, that is, if a constant is added to or subtracted from each term of an AP, then the resulting terms are also in AP. It means if we add a constant to each term of an AP or subtract a constant from every term of the AP, in such cases the common difference D remains same. It means what? Whatever is the common difference of the first AP after the operation, whichever the AP we are getting, the D of that also will be same. There is no change. The next properties we can have, if every term of an AP is multiplied by or divided by a constant, then the resulting terms are also in AP. But in these cases D will change. D changes. How it changes? In the first case, when we are multiplying the AP, suppose we multiply it by K, then in the first case we find the common difference of the new AP will be equal to K into D. In the second case, we will find that when we are dividing by K, the new D will be equal to D upon K. It means that will be divided by K for the new AP. In the next video, we will be learning about the arithmetic means and their properties. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.